Vectors have magnitude and direction. If you want to add two vectors, we do the following. You slide this vector, comes here, and from the end of the first vector, we draw the second one. And we slide this one parallel to itself and bring it here. Suppose this is the same vector. This is B. And then A plus B is a vector starting from the start of the first one, ends at end of the second one. So it's like that. This is A plus B. This is how vectors add. And because you make a triangle out of these two vectors, this is called triangle method. There is another method to add vectors, is by parallelogram. You make a parallelogram out of the two vectors. Let's say this is A, again, parallel to itself. It's hard to draw vectors exactly parallel and the same magnitude, that's supposed. And then start the other one also from the same starting point, this way. This is B. And then make a parallelogram out of these two. Then from end of A, you draw a line parallel to B. And from end of B, you draw a parallel line to A. And where these two meet, you draw a vector from this common starting point to this point. So this will be A plus B. You see that this is equivalent to that because you can basically slide this B from here to here. It will be the same thing, right? This is called parallelogram method of adding vectors. Now, something that you can observe from this is that A plus B is the same as B plus A, right? So A plus B is equal to B plus A. You can see this property of vector addition. This is called commutative property, right? Now, what is a zero vector? You can introduce zero vector. Zero vector is a vector whose length is 0. An undefined direction, because you cannot define direction for a zero vector. All right, this is a zero vector. And then we can introduce negative of a vector. What is negative of a vector? Normally, negative of a vector is a vector that you add to that vector, and the resultant will be zero vector. Add A and B and get 0, we say B is equal to negative of A. And see, if this is A, B has to be exact opposite and the same magnitude to be negative of A. So this is A, this is negative of A, this is B in this case we call it. Right? So negative of a vector is the same magnitude and exact opposite direction. Okay? We call it anti-parallel. They are anti-parallel to each other. How do we subtract two vectors? If you have vector A and vector B, and you want to do A minus B, how do we do that? Yes?
You take the negative of one of them and add.
That's right. We add negative of B to A. Right? Instead of saying A minus B, we say A plus negative of B. Right? And that's the same as subtracting. So if I have A, let's say A is like that, and negative of B is the exact opposite, and I start from here, get like that, this is negative B, and I know how to add two vectors, so A minus B will be this one. Alright, so we know how to subtract two vectors. Some people say in order to do A minus B, you start them from the same point. If this is A and this is B, start them from the same point, and then A minus B will be from the end of B to the end of A. That's the same thing. See, this now is the same as this, right? It's the same magnitude, the same direction. Right? Now, Another thing that's very important is how to multiply a vector by a scalar, by a number. Scalar multiple of a vector. Let's say we have a vector A, we want to multiply by 2, a number. What should we get?
2A.
2A, but what is 2A? We want to be consistent with vector addition. 2A should be A plus A, right? So if you add A and A, what do you get? If this is A, and you add another A to it, starting from here, do another A, right? And this should be, from here to here, should be 2A, right? So 2A is another vector that's the same direction, but double the length, right? So if you draw this now, this is 2A, is the exact same direction, but double the length. And similarly, 3A is the same direction, 3 times the length. And what is 1/2 A? Yeah, half the length, right? Because if you add 2 1/2 A, you should get A, right? So again, you can say 1.5 A, just 0.5 A, or 1/2 A, and so forth. But if you multiply by a negative number, it flips over. So yes, if you have something like that, you can call it negative 1.5A. It's the opposite of 1.5A, right? The same magnitude, the opposite direction. So multiplying a vector by a number or a scalar just scales it. If the number is negative, it also flips it around. Okay? That's called scalar multiple of a vector. All right. Now we can say why we have vectors in physics. Where do they come into physics? It's very important. Why do we use vectors? Let's say you go from city A to city B. Your displacement vector is this. This is displacement from A to B, right? Displacement vector. And then you go from vector point B to point C. Sorry, these are points, not vectors. Point B to point C. C is here. Then this is another displacement. Let's call this first displacement. This is second displacement. And these are vectors. You go this way, and then you go this way. What is your total displacement from the beginning? From A to C, right? So your total displacement is this way. So this is d total. And the way this d total is related to d1 and d2 is by vector addition. So this is why displacement is a vector. The way it behaves like vector. So displacement is a vector. Because it acts like a vector when you add two displacements. The first vector we have is displacement. But there are things that don't have sense of direction, right? Like what? Speed, or before we get to speed, time is just a scalar, right? Time is a scalar. Mass is a scalar. Speed is another scalar. I will tell you why the speed is a scalar. And then here we define velocity, an average velocity. Average velocity is displacement divided by time, right? It is like multiplying a vector by a scalar, because inverse of time is a scalar. Multiply that vector by a scalar gives you another vector. So velocity is a vector. Instantaneous velocity becomes also a vector because we get the limit of this as t goes to 0. We get the same vector. And then we define acceleration based on velocity, right? We subtract two velocities, b final minus b initial, these are velocities, divide them by t, you get acceleration, right? So acceleration is a vector because we built on vectors. First, displacement is a vector, makes velocity a vector. Velocity is a vector, divided by time is like multiplying by a scalar, makes another vector. And then we have Newton's law, we say F equals ma. Mass is a scalar, multiplied by a vector, which is acceleration, another vector, which is force. F equals ma. Right? Once the acceleration becomes a vector, multiplied by mass, force becomes a vector. And then momentum we define as mass times velocity. Because velocity is a vector, you multiply by a scalar, it becomes another vector. So momentum is a vector. The magnitude of a vector is a scalar. Magnitude is just the number, how big it is. So the speed is a scalar. And then you build everything from the speed, like kinetic energy, call it K, is 1/2 the mass times speed squared. This is a scalar, scalar gives you another scalar. So energy becomes a scalar. And length, volume, all of these are scalars. Length, area, all of these things are scalars. There are lots of other, temperature, pressure, all these things are scalars. We will see more of those later, but I just wanted to tell you, anything that you build upon vector so that they give you another vector, that becomes a vector automatically. And that's why we have vectors in physics, and these are scalars. We have vectors and scalars. So that's how vectors come to physics, and why we have this chapter devoted totally on vectors. So that we learn how to deal with vectors, and that's very important because really most of the difficulty people have with physics is because they don't know how to handle vectors. This chapter is about that, so we're going to talk about all of them. All right. Don't worry about these things now. Let's talk about vectors and how we handle them. Next thing I want to introduce is unit vector. Unit vector is a vector whose length is 1 unit. Means that its length is unit. If you want to make a unit vector in any direction, take any vector in that direction and divide that vector by its length. Then automatically it becomes a unit vector. Usually if you have a vector A, and if you divide it by the magnitude of A, it becomes a unit vector in the same direction. And we call this a hat. And a hat, we put a hat on any unit vector to show that it's a unit vector. A hat is just vector A divided by its magnitude. With our notation, it becomes like this, right? The vector A divided by A, which is its magnitude. Then it's a vector that is in the direction of A. Right? This is unit vector. There are special unit vectors in our coordinate system that I'm sure you've heard about. If you have a coordinate system x and y, there's a unit vector in the x direction. Yes? Yes. Unit vector in the x direction, we call it I hat. Some books call it x hat. But usually we call it I hat. And that's in the positive x direction. There's another one in the positive y direction. We call it j hat. And these two vectors are very special because of what we're going to see. These are called I hat and j hat, or coordinate system, Cartesian coordinate system unit vectors. Right? Now, let's say you have a vector here. Vector A is starting from the origin to any point in the plane. Right? That makes a vector. Any vector that we have in the plane, we can always write it as the sum of two vectors, one of which in the x direction, and another one in the y direction. For example, because of parallelogram method, you see here, if you consider this one vector and this one the other vector, adding these two vectors gives you A. You can always do that with reverse parallelogram method, right? With reverse parallelogram method, you can always find two vectors, one of them in the x direction, one of them in the y direction, positive or negative x direction, positive, negative y direction. Some of these two vectors become A. So let me call this one a x vector and call this one a y vector. So if that's the case, A can be written as ax plus ay. Right? These two are called component vectors of vector A. These are not components yet. They're component vectors, means two vectors that add up to A. But because ax is in the x direction, we can write ax vector as a number times I hat, right? Because they're in the same direction, either in the same direction or opposite direction, right? If ax is in the other direction, that number will be negative. Times I hat gives you that. So ax vector can be written as a number times I hat. That number, we give it a name. We just call it ax without the arrow. It's not to be mistaken by magnitude of ax. Because magnitude of ax is positive only. But this ax can be positive, can be negative, right? This can be positive or negative. Similarly, ay is equal to another number times j hat. We call it ay without the arrow on top. And these ax and ay are two real numbers and can be positive or negative. And we call them components of A. Components of vector A. And this ax and ay can be positive or negative, and they are components of A. So A, instead of this, now we can write this. A is equal to ax I hat plus ay j hat. And these two are components, can be positive, negative. I hat and j hat are unit vectors. And because of that, this is called unit vector notation of vector A. So when a vector is written in terms of unit vectors, you can readily see what the components of that vector are. The factor in front of I hat is one x component of the vector. Factor in front of y hat is the y component of the vector. That makes sense? So we introduced components. Component vectors are not components, they are vectors. But these are numbers we call components. And notice that ax and ay, if you write them as a pair, this is the coordinate of the tip of that vector A, if it starts from the origin. Point in this coordinate system is ax, ay. And you know about coordinates of a point can be positive and negative. In the first quadrant, both of them are positive. And here, the y component is positive, the x component is negative. In the third quadrant, both of them are negative. In the fourth quadrant, x is positive, y is negative. Right? And when the vector is along one of the axes, then it has only one component. So I want to emphasize here, we have three different things. The vector itself, see, distinguish between the vector itself, the magnitude of the vector, and components of the vector. If you distinguish between these, when you want to talk about the vector, make sure you know which one you're talking about, then everything will be easy. Most problems in physics come from when the person doesn't distinguish these things. Components, as I said, are scalars by themselves. Can be positive or negative. But the magnitude is another scalar. It's always positive. But the vector itself has magnitude and direction. Is it positive or negative? What do you think?
Depends on the direction.
When do we call a vector positive or negative?
Going left or right.
No. That's very important. Positiveness and negativeness do not apply to vectors. So you never call it positive or negative. It's the same as saying, like, if capital city of Cambodia is positive or negative. Right? It doesn't apply. Some concepts don't apply. It's like, what is the smell of Tuesday? Doesn't have a smell. The smell is not made for Tuesday. Right? It's the same thing. Positiveness and negativeness is not made for vectors. It's made for scalars. Right? You can say the magnitude can be positive or negative, but in our case, magnitude is always positive. These can be positive or negative. But this doesn't apply to them. So if you say a vector is positive, it's nonsensical. Right? The same as saying color of Tuesday is red. It's the same kind of thing. So just magnitude and direction. When you want to specify a vector, you say, okay, it is this big and it is in this direction. That's all. Magnitude is a number with the positive value, not direction. And these are two numbers that can be positive or negative. Right? So sometimes we write the components in terms of magnitudes, because magnitude is always positive. If it is negative, negative comes in front of it. It becomes more clear. We're going to have examples for that.